Hi, and thank you for listening to Dream 10X Radio, where we interview people attempting to live extraordinary lives. Our twofold purpose is to both direct and inspire people bold enough to do the same. Dream 10X. Face your fears and make your life count. Hello, Dream 10X. Welcome to episode 32. It's your boy JC. I'm here with my lovely wife, Dr. Capel. How are you doing this evening?
Good. How are you doing?
This afternoon, sorry.
All of the above.
Good. We're sitting outside enjoying the warmth. It's about 90 degrees. Feels good though. We were just reminiscing about our time in 2017, about the same time of year, in Boom, Belgium, when we went to Tomorrowland, listening to a bunch of EDM DJs, having a great time with people all over the world and the locals from Belgium. And there were these great food places there as well, and one of them was called Balls of Glory. Tell us about the Balls of Glory, Dr. Way.
They were so delicious. They were these giant meatballs, and we stuffed our faces with them.
And the mashed potatoes and gravy was incredible with a beer. It was just great.
Oh, my mouth is watering.
Very good. But a lot of the pictures that we took there we used on our Dream 10X website. So anyway, we were just reminiscing about those good times, and we hope that Tomorrowland can open again one day soon after this COVID thing is over and people can start enjoying the music festival. It's an awesome place to go. A lot of fun. Highly recommend it. And about that same time is when I started playing around with machine learning, and I'm not going to use the word artificial intelligence. I'm going to try not to because I don't know what it is. I don't like the term. So machine learning, and machine learning relative to a book I just read called The 100-Page Machine Learning Book by Andriy Burkov. And it's actually 130 pages, not 100 pages, so it's a little false marketing there, but it's very intense, and we've talked a little bit about, do we really want to get into these technical terms and technical things on this podcast?
Our one listener, Sasha Rosen, who she and I were in the Navy together, and I haven't seen her in 21 years, and I saw her for the first time last weekend, so it was really cool. But she's an engineer, and she loves our podcast. She said she listens to it, so she might actually really appreciate that.
Awesome. Thank you,
Yay,
Sasha. 21 years? I didn't think you were older than 22.
Yeah, 25.
Wow, that's cool.
I got my doctorate when I was 6.
What is your doctorate in again, by the way?
Organizational learning.
Organizational learning. Cool. So you are always talking to me about learning and neural stuff that I don't know. Neuroscience, yeah. So it's interesting how my interests in machine learning and your interests in learning and neuroscience and human learning kind of intersects. And so you're always asking me things, about technical things to see how it might apply to the, what do you call it, qualitative analysis you do in the area. Is that right?
Sure.
Is that... Am I making a fool of myself again? No. Anyway, human learning and machine learning is very fascinating to both of us. And I have been thinking a lot about how we learn, especially relative to my desire to learn more about this new this new field of technology. So I remember when I first started learning Java programming language, I really had to, and I learned a lot of it by reading books on how to structure the programs and the syntax and all that stuff. And I really had to focus and really ponder the meaning of the meaning of the code and how it was all working. And it took me a long time to kind of, I don't want to use the word meditate, but it really was meditate and think about what the text meant, what the language meant, and then I had to take what I was reading and actually do things with my fingers on keyboards.
So it's amazing to me because it's essentially learning a new language.
But I didn't actually learn it until I put fingers on keyboards and started writing programs.
Okay.
Maybe there's a slight nuance there between what I was trying to say, that in learning that thing, that Java programming thing, that's kind of how I went about it. and it didn't really start to sink in until I started building programs myself on a keyboard and an editor and compiling it and running it and seeing how things actually worked. And so in machine learning, this field of machine learning, it's kind of the same way. I'm reading this book. I read this book, the 100-page machine learning book by Andriy Burkov. I can't say I fully understand it, but I'm having to focus the same way on this book as I did initially when I was learning Java. But this is even harder. This is much harder than learning a programming language. This is much broader in scope, and it's much deeper. There's a lot of new concepts to learn that I wasn't fully aware of, and I want to try to take a high-level perspective and simplify some of the things I'm learning and present them to you in an attempt to learn it even better. And maybe I'm presenting, and I'll probably present it wrong, but I want to try to do that by talking on this podcast just to see how, see if I can get some of this stuff to sink in and see if it raises some more questions that don't make a lot of sense that maybe I need to dive in deeper and figure out.
Makes sense.
Does that make sense?
Absolutely.
There was a guy I worked with, and I noticed in him that he would love to try to explain things to people even though he didn't know it. And he was doing that because that helped him learn it better. We did that all the time in teaching. And that's new to me. Like, that was not something I ever would try to do. So I want to try to do that now. I want to try to explain to you maybe the first chapter that I read in this book to see, is it sinking in?
That sounds great.
So what is machine learning? Machine learning is basically taking a bunch of data, running it through an algorithm, and having that algorithm interpolate what the rules are that it should apply to that data to get the results that it needs.
So kind of like logic modeling?
Kind of like logic modeling. But
if then?
It builds those rules, yes.
Okay.
The way I typically program right now is to write those if-then statements. But this is interpolating those statements from the data and the algorithm that you use to interpret that data.
So it's thinking.
It's not thinking. It's not thinking. It's not AI. There's nothing artificial about this. It's just an algorithm. It's just a statistical model. Have you ever modeled a financial statement? Have you ever modeled your net worth and tried to predict using your model what your net worth would be? No. I do that all the time. And all I'm doing is, calculating how much money I'm saving per month, and multiplying that by 12, basically, and pulling in some other inputs like how much credit card debt I have, how much our mortgage is, how much, blah, 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 all those things to figure out each month what the net worth is that we have. And then, from a historical perspective, you can kind of see how your net worth is growing or shrinking. Hopefully it's growing. And that you can build a mathematical model from that. Does that make sense? Does that make sense? That makes sense. You can see how things are growing or shrinking from a historical perspective, and then you can build an algorithm to kind of fit that data. Yeah, that makes sense. And then you can use that to project into the future. Well, where are we going to be at in 10 years? And is there something we need to do to, modify, if we have goals 10 years down the road and we're not hitting that 10-year goal, what do we need to do to our model, the data in that model to get where we want to be? That's what machine learning is. All it's doing is building a model based on the data that you feed it, and it's inferring rules from that data and that algorithm, and then it's that's why they call it learning, is because it's building those rules by itself. It's building those rules by itself. It's not intelligence. It's not artificial intelligence. It's programming. It's just a different way of looking at programming. And programming is not artificial intelligence. Programs are not artificial intelligence. They're just doing what you tell it to do. The machine learning thing, it infers rules. You're not telling it explicitly what to do. And so I think a lot of people are like, oh, this is magic. This is artificial intelligence. It's not magic. It's not intelligence. It's just deriving rules from data is really all it is. And so before I want to go into any more of that, I did want to say that from my perspective of trying to learn more and more about this field of machine learning, my first forays into the field has been to actually use models that other people have generated, other machine learning models to do various things that other people have created. And my first experiences have been with those models built by Amazon to run in Amazon Cloud, because it's so easy to get involved with machine learning by using a cloud provider, because they have infinite amounts of resources, computing resources, and they make very simple interfaces to use those very complex services, very complex machine learning models. Does that make sense? So, for example, my first foray into machine learning was to start programming Alexa skills. Have you used Alexa?
I have used Alexa.
In fact, Dream 10X has an Alexa skill.
Oh, why don't you show it to us?
Well, I won't show you, but you can hear it. So here, Alexa, tell Dream 10X to find episodes on artificial intelligence.
I found 3 matches for artificial intelligence. Episode 18, Thinking About Human and Machine Learning. Episode 19, The Age of Spiritual Machines by Ray Kurzweil. Episode 31, Genius Makers, Marketing Artificial Intelligence.
That's so cool.
So then you can go on and say, Alexa, play episode 31 about, or whatever episode that you want, and it'll show that she's not she, it's a machine. It will play the podcast for you. So I started playing around with Alexa skills, and first one I built was using Node.js. You know what Node.js is?
No idea.
It's just a JavaScript-like programming language. Very simple syntax. And so an Alexa skill is not machine learning either. It's just a program. But that program calls application programmer interfaces that live in the cloud, in Amazon Cloud, that in turn invoke complicated machine learning functions. And that's how Alexa knows how to interpret your voice. So your voice goes into the Alexa, it gets converted to binary data that gets sent to the cloud, which gets interpreted in a machine learning model that can convert that to something, text or something like that Alexa knows how to interpret, and then knows how to call the appropriate endpoints, utterances in your skill, the skill that I wrote, that does certain things. So I don't have to know what the person is saying. I just have to define key utterances. Like, my skill name is Dream 10X. And so that's an angry bird. We're sitting outside. We have birds and dogs out here, so pardon the noise interruptions. So yeah, there's nothing really that difficult about using a complicated machine learning model in the cloud. The Dream 10X model we just listened to is written in Python. I don't know if you've ever used Python.
Is Python a language too?
Python is a scripting language, just
like Java?
Like Java's not a scripting language. It's kind of a compiled language, but...
Is R the same as Java?
R is not the same as Java.
So no R?
No R. I haven't used R in a while, so no R. Is that a pirate joke? Oh goodness. R. R is used for data analysis as well, but I don't know if you could characterize R as a language, or maybe it is, or a tool. I think R is a language. I'd have to look more into that. But anyway, so Alexa skills can run in Python and Node and Java, and it's not machine learning. You're using a model that's already been pre-built to do things. When we went to AWS reInvent in, what was that, 2018, after we went to Belgium?
Mm-hmm.
And I remember sitting in the audience listening to the Andy Jassy keynote, and in the keynote he mentioned that they were going to have a new class on deep learning using a hardware device called Deep Lens, that anybody who participated in the class could get a free Deep Lens and play with. And all of a sudden, everybody went crazy trying to sign up for that class. and I knew I probably wasn't going to get in, and I didn't. I think I only had my phone, and my phone was being really slow, and the reInvent app was kind of wonky, so I couldn't get into the class where other people had laptops and they were getting in. I was so mad. I mean, the frenzy was insane getting in there, and then I remember going in the hallways where people were lining up to go in the class, and the wait list people were in line, and they were like going around the building. The line was going around the building, and it was just insane. People were going nuts to get in there. That's how popular this machine learning stuff was back then, and it's even more popular now, I think. But that was really kind of crazy. Almost, it was an insane time. Somehow I ultimately got into one. I think it was late at night. They opened up some
first thing in the morning. I can't remember which.
Yeah, it was some off hours thing, and I was like, "Shoot, I'll go. I don't care."
Yeah.
And and I had to cancel. I was gonna do some other thing, some
like
helicopter ride or something,
yeah.
and I canceled that because I really wanted to get into this deep lens thing. So got in there, and it was just awesome, learning to use this camera, basically this camera device that ran some AWS stuff on the edge, on the actual camera. You could deploy to the camera using all these pre-generated models. And that was kind of like the first time I really got the concept of a model. I was like, well, what is it? Okay, I'll just follow the steps. I'm not really sure what a model is and why I got to put it on here. This model can take images that it's seeing in this video camera, and it can detect faces and people, and it can detect dogs and whatever, and you can tweak it and to do. And wow, this is fascinating. This is really cool. And of course, the tutorial during the class was a hot dog, no hot dog. A throwback to the Silicon Valley series on the same thing, the thing that Jin Yang developed. And that was just awesome. It was a lot of fun. Got one of those cameras, brought it home, and then you and I did a little hackathon. We played around with it, and so slowly but surely, it's starting to sink in how this machine learning stuff is working. So, but still, there's a lot to learn, and this book helped me get my head around a little bit more some of the technical aspects of how those models are actually built. So far, I'm with you. I think I'm tracking where I'm at as well. So the real complexity then comes down to how do you generate the model? That's like the real meat and potatoes of machine learning is the model. And I don't know if it's fair to liken a model to a brain, but I kind of think about it like that, because the algorithms that you use to feed in your data, you can kind of liken those algorithms. Those are the neural networks. There's different types of neural networks, and neural networks are kind of like modeled after the neurons in the brain, right? So that's kind of where things have been going. I think the mindset of the scientists and the mathematicians and the philosophers behind this whole field have kind of tried to model things after the human brain as much as they can, even though probably technically it doesn't really model neuroscience. It doesn't really match neuroscience.
But if you look at it from the perspective, okay, see, the algorithms are how the brain in machine learning works. It's the same with learning theories. So we talk about Dewey. I talk about Dewey all the time, and Bateson. That's how the human brain works. So it's the learning models for humans are the same as the algorithms for machines. It's just how we process information and learn information. Mm-hmm. So I think it's similar, just in a different way.
Right, and I just started to come to that conclusion as well recently. I was reading another book, I forget which one, but it talked about how your view of the world is based on models. Mental models. And that really got me thinking. Mm-hmm. Again, the word model, it's how you interpret data.
Yeah,
is really all it is.
And
pretty
the
simple.
algorithms for that is all based on past experience.
Right.
Exactly. And the neurons that your brains have created in those neural pathways. So it's the same thing. It's the same algorithm, just in a different.
Right. And the other fascinating thing is humans can iterate on different experiences. Mm-hmm. And they can change their models based on those iterative experiences. And that's exactly how this field of computing works. And in fact, I had a dream last night, because I've been thinking about this machine learning stuff. I had a dream about I was working with somebody else, and we were building pipelines to iterate over the different types of algorithms that could be used, the different types of data that could be used to feed into those algorithms to generate different models.
That's cool.
And the reason for the pipelines and the iterations was to refine the model to get better and better and better. But the key word was pipelines. And anyway, that was the dream. I saw in my dream, a list of iterations running, and each one was a pipeline to generate a new model using different parameters and different algorithms, tweaking the data, whatever.
That is cool.
And I don't know where I came from, but it makes total sense. When I wake up, I was like, oh, this makes total sense. It's just like humans, like we just talked about, except computers can do these iterations so much faster than humans can. And I guess that is the real one thing that really kind of scares me about machines, is that they can go through iteration. They can iterate so much faster in the virtual world than we can in the real world to learn things. Anyway, I'll just leave that there. But that's one little key fascinating point that I've been pondering, is the iterative cycle of learning. So I wanted to get hands-on. So now that I read this book, I wanted to find what is the simplest example I could build with my fingers on the keyboard. So I've taken Andrew Ng's Stanford machine learning guy class on machine learning on Coursera. I've been through the whole thing. You develop a Python program to recognize, it's a cat recognizer. And so it was like a 4-week course. I did that, but I walked away with a lot of questions. And one of my big questions was, okay, I just developed this. And in that class, you don't use any frameworks. You develop the algorithms and everything, the math, everything from scratch, pretty much. I mean, you do use some Python libraries for that, but pretty much everything is from scratch. You're not using TensorFlow or any other fancy things like that. And one of my big questions was, okay, I finally built this thing in a cat recognizer, but it doesn't recognize my cat. So I took a picture of our cat Simba and I fed it in the thing and it didn't recognize it. And so I put a question out on LinkedIn just on a whim, like, oh man, I finished this class, but it doesn't recognize my cat. And my old boss that we interviewed, Dave Renson, who was at Google and now he's at Pendo.io, he said, oh, the way these classes and these algorithms work, they don't recognize cats unless they're on their back.
That's so weird. Why?
He's like, here, try this cat. He sent me an image of his cat on his back. Sure enough, it recognized that. I was like, what the? It was awesome.
Wow.
It reminded, that event reminded me of the times in Honolulu, Waikiki. I was trying to learn to surf for the first time. On my board, those those waves in Waikiki come in forever. So I'm like on my stomach, and then I'm struggling to get up, and then out of nowhere, this guy comes up beside me. He's a local. He's standing on his board. He holds my board while he's surfing the same wave, so I can stand up.
Wow, that is cool.
And then he goes off on his way, and I'm standing up, and I get to ride it, and I'm like, oh, and he's like, aloha, whatever.
That's
and I'm
awesome.
like, damn, how did that happen? It was amazing. So it kind of reminded me of that. Like, you're struggling to do something, and then somebody comes out of the blue and so just holds this one little thing, so you can get up the rest of the way. And I'm like, oh, that's cool. I love that experience, that analogy.
I love that. Yeah, that's beautiful.
So anyway, we go through this class. Another question I had was, okay, where does the model live now? Like, how do I trained it to recognize these cats on their back. Like, I want to write a program now to do that, to use that model. Where does it live? And so that was like a burning question. I guess I could have asked in a forum. I didn't ask in the forum where the model lived. But anyway, so this past week, I was like, all right, what is the simplest hello world example of a machine learning program that I can write that helps explain kind of how to structure a machine learning training set, how to train a model, and then how to use that model. Because the model is the brain, right? Mm-hmm. It's more than a function. A function is, you know what a function is?
No.
a function.
A conjunction junction. What's your function?
You know how in math where you had the F with the
FN,
X
yeah.
in it, and then the X gets passed to
Yeah.
some little math equation that spits out an answer. That's a function.
Yeah.
So a machine learning model is kind of like a function, except it can be much. You can pass in huge arrays of data that it can then go and calculate information on.
Okay.
So it's much more complex. It's the data that you can feed in there is much broader, much deeper.
Mm-hmm.
So anyway, why was I pointing that out? I don't remember. But anyway, so I wanted to build a simple model. I found an example on Google Developer how to use TensorFlow. It's basically a hello world. Hello world is like the simplest program you can write, and that's where you typically start. So when I was learning Java, it's like, all right, what hello world? Let me build a hello world Java program, public static void main, string, args, system out that print line, hello world, woo, compile it, yay! And then from that, a very simple building block, you can start to build huge complexity and knowledge on how to build that complexity. So, and then once you get your fingers moving on that simple case, then the more complex things start to flow. So hello world, machine learning, I developed that in Python, and I trained a model. The example is just an array of numbers, and the model learns the relationship between the numbers, fits a curve to that data, an optimal curve, to build the model. Does that make sense?
Like a learning curve?
So if you think of the numbers as a 2D array, and then there's a decision plane that is, so it tries to figure out the relationship between each set of numbers. So the algorithm tries to guess the function to derive the relationship between the numbers, and then tries to figure out the loss or the error in the guess, and then it tries to it uses what's called an optimizer to restructure the algorithm to guess again, and it iterates until it figures out the correct algorithm to determine those numbers. It basically plots those results on a 2D graph for this, and then hopefully you've got a clear plane between the yeses and the nos, so it can determine statistically what your answer is going to be for any value that you choose.
It sounds like those horrible SAT questions where it gives you like a set of numbers and you have to figure out the relationship between the numbers and you have to guess the next one.
Yeah, for this simple example, that's exactly what the problem is. For this very simple example, I'm just trying to explain how the machine learning algorithm is trying to derive what that function is to fit the data.
Yeah.
It's basically trying to derive a function to fit the data that you're feeding it.
That makes sense.
So then I use TensorFlow, very simple example there, very, very easy to use, and I don't even have to think about any of this math or anything because TensorFlow does that for me. So I'm not really worried about the complex algorithms and stuff. I'm not running it in the cloud. I'm running it on my local machine now, but I'm using the TensorFlow framework, which comes from Google, and I can run it all locally now, which is a big change, because before I could only have this complex capability by running stuff in Amazon Cloud or Google Cloud or Microsoft Azure or whatever. TensorFlow gives me the ability to run it locally now. However, it's abstracting a lot of the complexity of the machine learning algorithms and stuff from me. So I'm basically just calling one line of code to generate my model. I pass in the data that I want into this model. I tell it what algorithm to use and how big my neural network should be and all that. And it generated a model for me. And then my next question that I've had for a long time is, okay, I got this model. I want to use it. It's easy to use it, but I don't want to have to build it every time I want to use it. How do I save it and use it in other programs? And so, very easy to use. You just save it. There's an API call to just save it to a file, and you got the model that you generated.
Oh,
and
that
then
is easy.
Then I just, in another example, I just load it from a file,
Yeah.
and I don't have to train it. I just load it from the file, and it's right there. And now I can use that model to calculate numbers in the future,
Wow.
or numbers elsewhere on the plane that I didn't train it to learn.
Yeah. Huh.
The interesting thing is that it statistically, like, so there's there's an X and a Y set of, they call them vectors of data, of scalar data, just numbers, and it guesses the relationship between the two because there's a pattern, but it's you only feed it like 10 sets of numbers, right? And so it then figures out what the relationship is between those numbers, and then you can tell it, all right, tell me what the value of Y is going to be at the 100th element.
Whoa.
And even though you didn't tell it, what those values were, it can now figure out what those values are from a statistical point of view. So
Wow.
it's not exact. It'll be like, oh, statistically, I recommend that this number is probably going to be, something, but it's not going to be exactly. It'll be close to it, but not exact. Which I thought that kind of blew me away. So a function will tell you exactly what that number is. It'll do it fast. But this machine learning model is figuring out statistically what that value could be.
Okay.
Does that make any sense?
I think so.
So anyway, that's what I learned this week. I didn't talk about supervised learning, which is what this is. And we're 30 minutes in, but I do want to talk a little bit about supervised learning versus some of the different styles of learning. So with machine learning, you have supervised learning, you have unsupervised learning, and you have semi-supervised learning, and you have reinforcement learning. And I don't want to get into any of those. No, I'm not talking about any of those other than supervised learning. That's what I'm trying to learn. And with supervised learning, you have a set of data that you want to train a model with. And in that set of data, you have a label to define what it is. So if you're talking about cats, you've got a bunch of cat data and then a bunch of non-cat data, and your label says this is a cat, or this is a dog, or this is whatever. And that label helps the model figure out what it is statistically. Mm-hmm. Does that make sense? That's supervised learning.
Yeah, so it's looking at all the pictures and finding out the similarities between all the pictures and saying, okay, then that's why it's not recognizing the cat on its front, because all the cat pictures that it's saying it's a cat is on its back.
Yeah.
Okay.
Right.
Yeah.
Yeah, it was trained with cats on the back.
Yeah. Yeah.
Well, I didn't know because I didn't look at it as training data. So that's what supervised learning is. And I was thinking, in the real world with humans, supervised learning is like us going to school, like public school or going to college. We're getting fed data and we're being told what that data is.
Vygotsky model. Yep.
What's Vygotsky model?
Vygotsky. He's Vygotsky and Dewey are kind of like foundational theorists, and Vygotsky is like different than Dewey because I'm going to tell you what to do. I'm going to supervise and tell you exactly what you need to know. Versus Dewey, it's like, okay, you experience it, and then I'm going to ask you questions so you can, and then help you find your own answers. Mm-hmm. So it's kind of like coaching versus mentoring. Mm-hmm.
And I started thinking about that, and I'm like, so in the world of machine learning, supervised learning is kind of, it's cool. Mm-hmm. It's really cool what the machine is doing and what it's able to infer from what you give it. But from a human perspective, I started thinking supervised learning is kind of that's broken. That's a broken way of learning something.
Yep.
I can't remember anything from college. I mean, I think I remember one law case, United States versus Eichmann. I think it was 1976. For some reason that sticks in my head. No, I can't tell you anything else I learned in college, because it was supervised learning, and I forget everything.
Yeah.
But the way I approached learning programming, I didn't learn in a formal setting. I taught myself for the most part. I did take some class to supplement things I was learning. But Java, I taught myself how to program because I was curious and I wanted to learn how to do it. And it's the same thing with machine learning. I'm using courses to supplement, but I'm not, I'm trying to explain that taking courses online it's not telling me everything I want to know. And the only way I can fill in the gaps is to be curious and to start asking, where does that model live, and figure it out. Through motor memory, building motor memory on the keyboard, learning how to develop the simplest programs, being curious about how to do things, and then go do things bit by bit. Build the simplest thing you can, and then slowly but surely build more complexity into it. That's how I'm looking at myself, and thinking that's how I learn best, is not just from a professor telling me how to do things. Like, that just seems like totally broken to me now at my stage in my career of how to actually learn things.
It's actually against how humans typically learn. Like, we do learn more by experiencing things and then reflecting on it. And sometimes you need to be told that sometimes, you touch the hot stove, and then you learn from there, oh, that stove is hot when it's red. So if you look at our school systems, the whole supervised learning is really trained still from the industrial age, where we're training cogs and wheels versus thinking. And versus where we'd have a more experiential system like you're talking about, like really promoting that curiosity of learning. Think of who we could be developing and those future amazing people and future thinkers.
Yeah, so to me, that's what intelligence is. That's the difference between machine learning and intelligence. And intelligence is curiosity and thinking about, what don't I know, and how do I learn that? How do I go learn it on my own? So that to me, that's really interesting. Like, college is not building intelligence, or I don't want to say that. That's probably a bad thing to say. But that structured learning is, I don't think that's really intelligence. And I think that's really interesting to think about. Maybe I'm totally wrong. Maybe I'm totally off base. But to me, the intelligence is the curiosity that we have as humans, and the motivation we have to go figure things out on our own, not to be spoon-fed or told what to read, or some structured curriculum. I don't think that's what. And if we're building that into machines, I don't think artificial intelligence is ever going to exist. So I think we really need to figure out what intelligence means.
So there's a book by Edward Hess that I'm reading right now, and it's awesome. And it's called Humility is the New Smart. And it's rethinking human excellence in the smart machine age. So it talks about exactly that. Like, what do we actually need to make ourselves better in this new world where machines can help us? And how do we change how we think and how we act and how we learn? And curiosity is like the fundamental piece of that.
What's that book again?
Humility is the New Smart.
Huh. I didn't know you had that book.
Yeah, I told you about it. And then there's also one called Hyperlearning, which I'm going to read next. Hyperlearning, How to Adapt to the Speed of Change. And that's also how to rethink and learn in the intelligence age.
Oh, those are awesome. So maybe you can talk about a book you've read on the next podcast instead of me. Give me some time to actually do some more reading. But the next book I'm reading is called A Brief History of Artificial Intelligence by Michael Wooldridge.
That looks interesting.
He's a Cambridge professor who's really loves artificial intelligence, and he's going to tell me more about the real deal there.
Sweet.
So hopefully that'll be coming up in the next podcast episode. But
I'm looking forward to that.
Yeah, just wanted to talk about my experiences diving into machine learning and trying to learn more about this field and get more experience. And it's a lot of fun. I really enjoy tinkering with it. And
I appreciate you talking about it at a very I'm non-technical at all, and so at a non-technical level, so that it's helpful to really get a grasp on it, because it is the way the future's going, and it's going to help me in what I do. So
yeah, I don't feel like I explained it well at all, because I don't really fully understand it.
Well,
so
we're going to keep plugging through this.
Working on
More episodes to go. This is day one.
So anyway, thanks for listening. We'll talk to you next time.
Bye.
Over and out.